So see the graph, we can clearly observe that TQ is nothing but turn off time of the device. Turn off time of the device. TC is nothing but circuit turn off time. Circuit turn off time. How can we classify this TQ and TC? TQ and TC both are not equal. If you see the graph here, you can identify the time for circuit turn off time is more compared to device turn off time. This is the best way of successful commutation. That means this is a successful commutation condition is TC should be greater than TQ value. Circuit turn off time should be greater than TQ, device turn off time. Then only the commutation will be successful. Otherwise, the commutation will be failure. Commutation failure. The not efficiently we are turning off the SCR. So this is a major condition. Then how to classify this TQ and TC means TC is nothing but the circuit turn off time. Circuit turn off time, or we can define like this. How much time, listen carefully, how much time you are applying a reverse voltage across an SCR. TC is nothing but the time, that is how much time we are applying a reverse voltage across an SCR is nothing but TC. How much time you are applying a reverse voltage in across the SCR, that is nothing but the circuit turn off time. After circuit turn off time, after circuit turn off time, that is TC value, the SCR is completely in off state. SCR is completely in off state, and it is able to block the applied voltage. Whatever you are applying, it will be blocking. The blocking capability will starts thereafter. That means TC is nothing but the how much voltage you are applying across an SCR is nothing but the circuit turn off time. Then what is TQ? TQ is nothing but device turn off time. Device turn off time is nothing but the current anode current becomes zero. If you see the graph here, TQ can be if you see the anode current from T1 to T4, almost all IA current is starts decreasing and reaches almost all zero and reaches steady state value almost all at T4. This TQ is the off time of the device, off time of SCR. Here we are using the device is SCR. So TQ is the off time of SCR off time. TC is nothing but off time of total circuit, or you can say how much voltage you are applying, how much time you are applying the reverse voltage, across the SCR. That is nothing but TC. For successful commutation, I am repeating, TC should be greater than TQ value. So TQ is again classified as reverse recovery time and recombination time. In power diodes, if you compare the reverse characteristic, in power diodes there is no recombination time. In power diodes. Whereas in SCR we have a recombination time, or you can say gate recovery time. That is a major difference comparing with characteristics in power diodes and SCRs. In SCRs we are having a gate recovery time, whereas in diodes there is no gate recovery time, because in SCR the excess charge carriers, when you are applying an excess charge carriers, that is when you are giving a command to SCR to turn off, then the excess charge carriers which are present in all the layers, actually SCR has 3 layers, or you can say 3 junctions, J1, J2, J3, and during the recovery time TRR, the excess charge carriers which are present in outer layers, P and N layer. Outer layers, previous class also we discussed that one. Outer layers, the excess charge carriers which are present in P and N layers are removed. 60% of excess charge carriers in the outer layer are removed at the time of T2. That means almost all the excess charge carriers present in outer layers, almost all 60% of charge carriers are removed at the time T2. And after the time T2, the remaining charge carriers present in the outer layer is completely trying to remove. Okay, trying to remove. That means during the time T2 to T3, the excess charge, the remaining excess charge carriers, that is 40% of excess charge carriers which are present in the outer layer are trying to remove. Okay, excess charge carriers. That is nothing but the recovery time. During that recovery time, TRR, the excess charge carriers, the complete excess charge carriers are removed during the recovery time. And whereas during the gate recovery time, in gate recovery time, the excess charge carriers which are present inside the junction are inner layers, or you can say J2 junction. J1, J3 are outer junctions. J2 is the inner junction. The excess charge carriers which are present in the inner junction are trying to remove, are removed by using recombination process. The excess charge, that is the difference. During the TGR, the excess charge carriers which are present inside the inner layers, or you can say at J2 junction, the excess charge carriers are removed by using a recombination process. Then how the recombination process will improve? That means, or you can say, what is the major parameter? Which affects TQ time? What is the major parameter which affects TQ time? That is, we need to identify the parameter. By varying the parameter, we can easily vary the device turn off time. Basically, TQ value depends upon three parameters. These also last class I discussed with you. So TQ mainly depends upon three parameters. The rate of change of anode current, first parameter. Second parameter is the magnitude of anode current, how much anode current we are applying before starting the commutation process. And the second one is the rate of change of anode current, or you can say commutation process rate of change of current, because that command you are providing for SCR by using a commutation circuit only. So depending upon the commutation circuit command, how the rate of change of current is varying. That is the second parameter. And third one is junction temperature. So these are the major three parameters on which the device, or you can say TQ time period will depends. So that means if you are decreasing any of these three parameters, then TQ value will decreases. If you are trying to decrease, if you want to decrease TQ time, TQ is nothing but SCR device turn off time. If you are trying to decrease turn off time of SCR, then we need to decrease any of these three parameters, that is IA value or di by dt or TJ junction temperature should decrease. So these are the things which we already discussed in the previous class. But remember one thing, power diode reverse characteristics and SCR diode reverse characteristics have some difference. In power diode, we have only TRR, reverse recovery time only. Whereas in SCR, we have additional time, that is recombination time, or you can say gate recovery time. So with that gate recovery time, what happens during this gate recovery time is nothing but, during that gate recovery time, the excess charge carriers present in the inner layer of the junction J2 is completely removed. So that is the thing you should remember. And TQ is nothing but TRR and TGR. And one more point I am adding again here, TC should be greater than TQ. Then how much factor it should be greater? That means that TC, I am saying that TC should be greater than TQ for successful commutation. To turn off the SCR, for successfully turn off SCR, the condition is TC should be greater than TQ. Then what factor I have to turn off? That is what is the difference between these two parameters? Or you can say on what factor this will be increased. That is, remember, that is a safety factor. TC is equal to safety factor times of TQ. TC is equal to safety factor times of TQ. That is the factor we should remember. Safety factor. TC should be greater than TQ means how much amount, how much factor it should be greater means safety factor. That safety factor should always be greater than 1. Safety factor should always be greater than 1. So TC should be equal to safety factor times of TQ. That is the relation we have to remember. And what is the need of reverse voltage? That is a major part of this lecture. What is the need of reverse voltage during this turn off process? What is the purpose? What is the purpose of reverse voltage? To see the diagram, so these are the topics which we already discussed. What, how to define TRR and TGR also we defined previously. That is TRR is nothing but outer layer excess charges are removed. During this TGR, inner layer excess charges are removed. Okay, these are things which we discussed previously, and these are the things. These are the basic stuff which we discussed. Just now we discussed at T1 and T2 what happens, and T3 also what happens. So just now we discussed. So these are the basic stuff which we already covered. Yeah, these are things. Yeah. This is also we covered in our discussion. What are the parameters and what parameters the TQ value will depend. All the things we discussed. If you want, you can refer. I'm giving the points for you for your reference only. If you want, you can refer further also. So same thing we discussed. So same thing, TC. What is TC? TC can be graphically defined from the graph itself. Also, we can define TC. TC is nothing but circuit turn off time. By using the graph, also we can define. That is the way. By using graph, we can define like this. That is the first statement. Anode current, from anode current 0 to becomes instant at which reverse voltage SCR can terminate becomes 0. That is, we can say TC at TC, both the anode current and applied voltage, reverse voltage should be 0. At a TC, the applied anode current, or you can say anode current of SCR and the applied reverse voltage, both the voltage and currents are 0. At TC, both the voltage and currents are 0. That is the time of TC. Okay, TC should be greater than TQ, which will for reliable commutation, or you can say successful commutation. And also there is a classification in STRs. If you see the third point, converter grade SCR. Converter grade SCR is nothing but which contains turn off time is 50 to 100 microseconds. Whereas fast turn off time 3 to 50 microseconds are called as inverter grade. Converter grade and inverter grade SCR. We have both two types of SCRs, converter grade and inverter grade, depending upon the turn off time. Converter grade has high turn off time when comparing with inverter grade. If you see the ranges also, inverter grade has 3 to 50 microseconds, whereas converter grade has 50 to 100 microseconds. And the fourth point is converter grade SCRs are cheaper, so that it is used for phase control rectifier. Phase control means we are trying to convert from AC to DC. And also we can apply in AC voltage regulators also. That is the application of converter grade. Whereas inverter grade is specifically used for chopers, inverters, and forced commutation circuits. For that purpose, we are using inverter grade. And this is the factor which we just now we discussed. TC should be greater than TQ for successful commutation, and TC value should be safety factor times of TQ. So this safety factor should be greater than. So if you consider TC is less than TQ, what will happen? If you consider this is the case which we need to cover. If the time period of circuit turn off time is less than TQ, what will happen? This will be explained clearly by using a graph. You can see the graph. So this is the question what I mentioned. Here for successful commutation, TC should be greater than TQ. But what happens when TC is less than TQ? That means, for example, for clear understanding, I am considering TC is equal to TRR. For example, TC is equal to TRR. That means TC time is less than TQ. That means reverse recovery time. That is, we are applying a voltage TC is nothing but the applied voltage, reverse voltage, how much time you are applying. That means TC is less than TQ means we are applying a reverse voltage, before the recombination process. Before the recombination process, up to that time only, we are applying a reverse voltage. That is the question which we asked. I think you are clear with this. First is, what I am questioning is, TC is less than TQ, what will happen? TC is less than TQ means we are applying a reverse voltage. Before we are applying continuously reverse voltage up to the recovery time. After that, we are removing the reverse voltage. That means before recombination process, we are removing the reverse voltage. Before starting the recombination process, we are removing the reverse voltage. Here comes the role of reverse voltage. That is a major condition. If you want to understand this process, we need to know what is the purpose of VRR. Okay. If you see the structure of SCR, you can clearly observe that. So this is the diagram of SCR. For explanation purpose, I am considering this. So if you see the anode is negative and the cathode is positive, you are applying a reverse voltage. Okay. Previously we discussed TRR and TGR is nothing but the TRR. During TRR, the outer layers P and N layer excess charges are removed. During TGR, the inner layer, that is J2 junction, at nearly J2 junction, we are removing the excess charge carrier. Okay. What is the purpose of reverse voltage means? We are applying a reverse voltage means what will happen? Reverse voltage is applied across outer P layer and outer N layer. That means the excess charge carriers are removed very fast. Due to this reverse voltage. That is a major purpose of reverse voltage. That means the entire process will be fast up. By applying a reverse voltage. The entire process, that a complete turn off process will be fast up. Or you can say in other words, you can say the turn off process time will be decreased. Because due to the addition of reverse voltage, we are again supporting the excess charge carriers are removed very fast. So the excess charge carriers which are present in outer layer and both in inner layer, both the conditions, the excess charges are present, but the major effect will be across the anode and cathode. That is outer P and N layer. So to remove that excess charge carriers, this reverse voltage will support to fast up the process. That is the major reason. That's why you are applying a reverse voltage during the process. I think you are clear with this now. So the reverse voltage will decrease the total time period. Because we are fasting up the removing of excess charges, both in TRR and TG. The entire process, that is TQ time period will be decreases. Means we are removing the excess charge carriers very fastly with the help of reverse voltage. Okay, so that is the concept. Now the question is, if TC is less than TQ, what will happen? That means we are removing the excess charge carrier before recombination starts. We are removing the reverse voltage. That means the internal junction J2 will not remove the excess charge carriers very quickly. Or you can say we are removing before starting the recombination process, we are removing the VR value. We are not supporting to remove the excess charge carriers very fastly. That is the meaning there. Whereas TC is less than TQ means we are assuming that TC is applied before TQ. TC time period is before TQ only. That is, we are applying only up to TRR. Then it will act as a diode without any gate control, because we are removing the VR voltage before recombination. Before starting the recombination, we are removing the VR voltage. Then the SCR will act as a diode. Simply it will act as a diode. The characteristics will be similar. Okay, simply it will act as a diode. There is no gate recovery combination. It will act as a diode. I think you are understand clear with this. So that is the concept of VRR. Okay, this is all about the turn off characteristics. What is the need of turn off circuit. What is the need of turn off circuit? What is the purpose of turn off circuit? Turn off means what is the condition? We already know. Turn off means anode current should be less than holding current. Anode current should be less than holding current. That is the purpose of turn off. Because we are trying to turn off the SCR means we need the condition that anode current should decrease and reaches the below holding current. Below the holding current, then only you are getting the SCR will be in off condition. That is the condition we require. For decreasing anode current, we required three types of circuits, or you can say three types of commutation process are there. Three types of commutation circuits we require. For decreasing IA value less than holding current, we have three classifications of commutation circuits, or you can say turn off circuits. Turn off circuits are classified into three types based upon the procedure how the anode current is decreasing below holding current. So first one is, if the entire SCR is connected to AC supply, listen carefully, the SCR is connected for an AC supply. AC supply means we already know AC has positive peaks and negative peaks. Positive cycle is also there, negative cycle is also there. During positive cycle, anode current is increasing, or you can say SCR is turn on. What happens? IA is 0. When IA will be 0? First, initially we are applying IA, that is a SCR is turn on means SCR is turn on. Initially SCR is in on condition means IA is flowing in the SCR. Okay, IA is flowing in the SCR. If you see, if I supply voltage, that is we can say supply voltage is AC supply, then anode current, that is supply current, AC supply current will automatically decreases the value to 0. Automatically decreases the value to 0. That is the itself, it can turn off the side. Yeah. So if you are giving AC supply to the SCR means AC supply will itself has, there is a possible of 0 current, because at a time period pi and 2 pi there is a possible of anode current should be 0. So anode current automatically it will comes to 0 value. Anode current automatically comes to 0 value, decreases and comes to 0 value. That means there is no need of any additional circuit to decrease anode current. So this will be happen only when SCR has an AC supply. This will happen only when SCR has an AC supply. Then anode current will automatically turns to 0 value. At time period 180 degrees and 360 degrees will get this condition. What happens if a DC supply is there? DC supply means continuously constant value. Continuously constant value. There is no possibility to naturally to comes the anode current to 0. So for that purpose only we required a separate commutation circuit, because DC supply has continuous constant value, so it will not automatically comes to 0 value. So for that purpose we required a additional circuit which is forced to decrease the anode current to 0 value. That forced, previously automatically it comes to 0 value when AC supply, that is nothing but natural commutation. Second one is forced commutation. It is applicable only when there is a DC supply. Forcibly we are decreasing the anode current to 0. And third case is also there, that is a load commutation circuit. Load commutation circuit means both R and